All right, more angle relationships, 21.2. We're going to do angle theorems of triangles. So all about triangles today. So I can describe and use angle theorems of triangles. So we're going to talk about two different theorems. One is the triangular sum theorem or triangle sum theorem. For a triangle, the sum of the three interior angles will equal 180. So if you add the three angles inside a triangle, they will become 180 together. Okay, so then we also have exterior angles, angles that are formed by one side of a triangle and an extension of an adjacent side. So I'll show you what that looks like when we get there. Interior angles, those are angles formed by two sides of a triangle, or the inside ones. So then we have what's called a remote interior angle. I accidentally wrote exterior angle, and so you need to cross off the word exterior and change it to interior. Okay, this part you just need to do, not write down. So an interior angle that is not adjacent, so not next to, an exterior angle. And we need that for the last theorem. An exterior angle theorem, the measure of an exterior angle, so an outside angle, is equal to the sum of two remote interior angles. So two angles that are not adjacent, not next to your outside angle. All right, so we're going to do triangular sum theorem first. So what I did here is I put it more in algebra terms, right? Algebraic, so triangle ABC. If I take a measure of angle A, add it to the measure of angle B, and add it to the measure of angle C, we will get 180 degrees. So that's what that word, the definition said, but this is in algebra terms. Okay? So we're going to use that to find a missing angle measure. So we have angle J, angle L, but we need angle K. So we take our three angles, 71 degrees, add it to 56 degrees, and add it to angle K, and it will equal 180 degrees. So you can kind of do this in two ways. You can subtract and then subtract, or the way I like to do it is to take the two measurements, add them together, 127 plus angle K equals 180. Then I'm going to subtract 127 from 180, and I get angle K equals 53. This is the way it needs to be set up. Okay, this is an 8th grade concept. It also relates to algebra. So it needs to be set up in an algebraic form. We are not doing simple arithmetic anymore. Do not set it up as just subtract, subtract. I need equal signs, variables, everything. All right, so I want you to do number 5. Set it up, answer it, and we'll go over that answer. Use the one I just did to help you with this one. Okay, I'm not going to do this one at all. Okay, so this one's a little different down below, right? This is down below, same page. We don't have any angle measures. They all just have variables. So we're going to do it the same exact way we did, except we're going to have to solve for n before we can solve for the angles. So we're going to go n, that's this one, plus half an n, let's just pretend I'm doing that one, plus a half an n, that's this one, equals 180. It doesn't matter if they don't equal numbers, I can still use the triangular sum theorem to solve for them. So half an n and a half an n are 1n, and 1n plus 1n is 2n equals 180. And then we will divide, and we should get that n equals 90. Now, that helps me with x. X is n, so I can just put 90 degrees right here. But for y and z, they are half. So for half n, right, I need to take, half n is half, there we go, of 90, which will then be 45. So then this one's 45 degrees, and this one's 45 degrees. So I have to plug it in then to find y and z. But notice I still set it up the same exact way as the last two examples. Okay, so the exterior angle theorem states the measure of the exterior angle is equal to sum of its remote, and I mean extra space, interior angles. Okay, so the exterior angle theorem states the measure of an exterior angle is equal to the sum of its remote interior angles. So we have these ones, they're interior. This is an exterior angle. See how they extended this side of the triangle? Okay, this is my exterior. See, it's on the outside of the triangle too. You can tell that it's on the outside. So an exterior angle is now on the outside of the triangle. Okay? And remote interior is this one, because see how it's not next to it? It's not touching it. This is its adjacent. And then this is a remote interior. They're across from each other. They can't touch. So here's what it's going to look like. I'm going to take the exterior angle, 52 degrees. I'm going to set it equal to a sum and adding of the remote. So these two. Those are my remotes. I'm going to go 4y minus 4 and then plus 3y. This is the one plus the other one. And again, these are remote because they're not adjacent to the 52 degrees. Okay, so we're going to solve it like an equation. 52 equals 7y minus 4. Now it's a two-step. Plus 4. 56 equals 7y divided by 7. And we get y equals 8. So what it's asking us to do is find measure of A and B. We had to do that to find y. All right, I couldn't do that. So for B, angle B, I'm going to go 3 times 8, and that's going to get me 24 degrees. For A, I'm going to go 4 times 8 minus 4. So that's 32 minus 4, and that'll get me 28 degrees. And that goes right there. Okay, so this is angle A, this is angle B. But we had to use remote interior angles to solve for them. Okay, for your turn, I'm going to set it up for you. So you're going to go 146 exterior, see, outside, is equal to the sum of the two that don't touch it. See, this is the angle that touches it. This is the angles that don't. So you're going to go 5y plus 3, then add 4y plus 8. These two added together. Okay, so go solve for y, and then plug it back in, and then see if you can solve for m and n. Use the example up above. We'll go over these in class. All right, so things to remember. Triangles equal 180. Exterior equals interior, spell that right, plus interior. That's kind of shorthand. All right, this isn't your independent practice is an exterior angle theorem. So that equals these added together. This angle right here, DEC is this one. So it's actually also your triangle sum theorem. So it's a mix of the two. So that's kind of nice. It's an example of both. You're going to need to do one to find out the other as well. Okay? All right, until next time.